Uh, the webinar today is called Considerations for a Slab-on-Grade Foundation. Um, I guess I could have also titled this Consider a Slab-on-Grade Foundation, because my background, if you've tuned into any of my webinars before, my background is from the construction side. I've done everything from construction management to site management to actually, swinging a hammer and doing some building. And I spent about a decade down south in the Charleston, South Carolina area. So my experience with foundations down in that area was all, I would say 90% slab on grade foundations, and the rest would be something simpler to a pier foundation. So, coming back up here recently, I've been doing a lot of discussions with people and builders. And one of the concerns that we're all hearing about right now in the industry is cost. And in my mind, one of the things that people need or can start exploring, like what's one of the ways that we can help begin to lower the cost, and bring these, single family homes, down to a price point that it opens it up to more people. And so that's really a reason what sort of got me started on this, this idea of a webinar on slab on grade foundations. Of course, there's a lot of things that go into picking what we're going to do, but a couple of things I want to talk about here. As first, obviously, our learning objectives, the understanding the most common types of slab on grade foundations, and how to determine which is the best for you or for your client. Compare the cost effectiveness of slab on grade foundations as an effective alternative to a traditional foundation. Look at the pros and cons of a slab on grade when you're comparing that to a traditional basement, or what we're consider a traditional basement, traditional foundation in Pennsylvania. And we're going to do a little bit of review of the codes as well. So, what are slab foundations, and how they different from other types of foundations? Common foundations in the Northeast U.S. We have full basement, we have slab on grade, crawl space, and pier and beam. Obviously, we do not see very much pier and beam for a lot of different reasons. The main reason we don't see pier and beam in our area and colder climates is they're extremely difficult to heat. All sides of your house at that point are surrounded by potential cold air. So when you're talking about utilities, plumbing, all these things, it's a very cost effective way of putting a foundation in, but it brings in a whole other host of problems when you're dealing with extremely cold climates. Full basements is something that we all are very familiar with. We understand it's a tried and true method here. People love it. There's a lot of reasons people like having a basement foundation, and it's just what we're used to. And slab on grade is something we don't see a lot of in our region. We do have quite a few actual slab on grade foundations in certain older neighborhoods in Center County, Pennsylvania. And those are extremely old homes. I would say most of those were built in the early 1900s, and I would say 90% of what I've seen out of those are the kit homes that you saw at the beginning of that century. You can order them from Sears, and you put a slab foundation and then they send this kit and you build it up. And a lot of those are still standing. In crawl space, you might see crawl spaces here for a variety of reasons. One of the reasons I've come across, and a lot of the reason is it's just too difficult to dig. There are certain parts of this state where there's just the rock shelf is so dense and hard, it's economically impractical to try to dig a foundation unless you're going to get dynamite in there and try to do something like that. But for us, basement is something we're used to, but what we're going to explore more today is the slab on grade. Again, a quick review of a full basement foundation. This is generally the most common type. What we have here throughout the Northeast, the benefits are accessibility. You have a usable space. It's a known product, and it's better suited for steep grade. So if you're living in an area, if you're building in an area where you have a very steep grade, and you're going to need to do a lot of grading and site work, putting a basement in helps a lot with that, and usable space. Yeah, they're usable. Most of the times when you build a new construction, most people don't have a finished basement when they're done with a new construction. And that's something that usually happens later. But it's still a usable space for storage, and you could put your mechanicals down there. And so in that aspect, it is a usable space right from the beginning. And what are the drawbacks? Their expense. If you look at the diagram here, it's a complicated system. You have a lot of different working parts. You got insulation factors, you got drainage issues, you got moisture issues, you've got grading and excavating issues. And they take, out of most of what we're talking about here, they take the longest to install, just through the complexity of putting one in. Slab-on-grade foundation it's a type of foundation where the concrete slab is poured directly onto the ground. It's exactly what it is. It's you're using the ground to support the slab. And there's, within that definition of a slab foundation, you have a T-slab foundation, you have a slab-on-grade foundation, and some people call those monolithic pours. It really depends on what part of the country you're at. As if you've ever worked in Northeast and somehow you've worked in another part, terminology is different. They might call something else that you would consider that slab-on-grade, and they're just going to call it a monolithic pour. But for us, our slab-on-grade, you can call it a monolithic pour. And also, that is something that I would see a lot of down south, just a typical slab-on-grade. And then you have a frost-protected slab-on-grade, or a frost-protected shallow foundation. It's basically the same thing as a slab-on-grade, except, obviously you're taking precautions. You're adding a little bit more to it, just because we are in a cold climate and you have to deal with frost and other things that I wouldn't have had to deal with down south. There was no frost considerations on the coast of the Carolinas. The most common types of cold weather climate in these situations for slabs are the T-shaped slab foundation and the frost-protected shallow foundation. Obviously, I'm referring to home living spaces. This is not taking into consideration, pole barns or anything like that. I'm talking about foundations for a home with living space in it. All right. Like I said, the only difference between a traditional slab and a frost-protected slab foundation is the integration of insulation to help prevent frost heave. T-shaped slab foundations. They are cold climate slab foundations, and what makes them good for cold climates is, where a frost-protected slab foundation is relying on insulation and heat from the building and from the ground. A T-shaped slab foundation is relying on depth to deal with the frost situation. So you're no longer, it's basically the same as a traditional basement footing. You're using the depth of the ground and getting down there deep enough that you're not going to have to deal with frost heave and other situations. These are pretty much straightforward to insulate. They're spelled out pretty clearly in the code what's required with the T-slab foundation and this type of foundation. They're a little bit more complicated, obviously, than a slab-on-grade or a monolithic pour, because you are having multiple steps in here, and you are going a little deeper with your grading and your excavating. Crawl space. yeah, these could be a good thing. Obviously, you still have your benefits of accessibility. So if you run into issues with, your plumbing or anything else, you can get down in there and you can do repairs. They offer termite protection as well. I mean, you are getting obviously you're off the ground a little bit, so you still have that protection from termites from the exterior. They're easy to insulate and they're more cost effective than a traditional full basement. Well, the problems are moisture buildup, pest infestation, and they do need regular maintenance. There's different ways to put crawl space in. There's conditioned crawl spaces. That's something that I'm not going to get into right now. But yeah, crawl spaces 30 years ago compared to crawl spaces now are two totally different things. So, but again, it is another type of foundation that we could see here. And again, I did talk about pier and beam. They're really relatively inexpensive to install. You do have easier access to utilities, but then also so does the weather. In cons, you can run into dampness issues down in the low country where we would have these. The problem we would have is there would be pools of water forming underneath there. And then if you weren't underneath there checking on these things, if you didn't grade it properly, you could have standing water underneath your house for a very long time. So you got to be careful of putting these things in and not, you still will need to grade so you get water flowing away from your building. And again, in colder climates, these are very difficult to insulate and your utilities become another issue. And you have potential for infestations. Obviously animals can get underneath there and all other things can happen with that. Design and construction considerations. When designing a slab-on-grade foundation, especially in areas where soil conditions vary, several factors need to be carefully considered. You want to ensure stability, longevity, and durability. Obviously soil type, that goes into considerations anytime you put a foundation in. Water tables, it's not such a big factor here. There are places within Pennsylvania where you do got to consider water tables, and that is more in areas where you have potential for wetness and dampness and standing water and like valley areas. The site grade, how steep is the site you're going to be building on, and obviously frost depth, but that varies. I think here we are about 36 inches to the frost line here in Center County, Pennsylvania, but obviously if you're building in your region, you're going to be more aware and conscious of what your frost considerations are going to be. Foundations aren't a one size fits all. Obviously, if you're just going to be putting basements in, then yeah, I mean, you can just put a basement under every house if that's really what you want to do, unless you run into issues like I said earlier, where it's just impossible to excavate. You have rock formations and other things that could potentially run into that as a problem as well. Again, your environment, your climate, your costs, key features. Your environment, like I said earlier, it's your soil condition, the grade of your lot. These go into a lot of things that can help narrow your choices down. Your climate zones, cost. This is where I'm hoping we could talk more about today is cost. Some foundation types are more cost effective than others. And so consider your budget. If this is a house for you, obviously stability and structural issues are the number one concern of any foundation. But beyond that, other questions need to be asked, and we'll talk more about that as well. And again, key features, what you want from your foundation: livability, living space, access to utilities, all these things. What do you need? And this is something that you want to get your clients' input from. Yes, obviously, without a doubt, structural support is the number one consideration that can't be overlooked. But once that's taken care of and you understand, all right, obviously we want a stable house. We want a foundation that's going to last 50, 100 years. What do you as an individual want your foundation to do for you. I've talked to a couple of older couples in my area, and they're looking to build their end of their last home, is what they're saying. They want a house that they can move into, and then they spend the remaining years and not have to worry about moving out. And having discussions with them, one of the things that I would ask them is like, how, you know, cost is always one of the things that they talk about. It's not the main consideration, but and when I talk to them about, what kind of foundation they want, and I asked them, have they ever considered using a slab on grade foundation? They don't really understand how that is or what that is. And so when I explained to them, slab on grade foundation is structurally like any other foundation, but you just don't have, obviously you don't have your basement, so you don't have that storage there. And if that's an important factor to you, then that is. And the more of these older clients get, the less a basement matters to them. When I really would talk to them about, is like, yeah, they love the storage aspect of it. But as clients get older, and as they get older, they said they really don't want a basement for them, because they don't want to have to be able to go down in there. They don't want to have a space that they have to monitor and take care of, and all the other things that go along with having a basement. So for some people, a slab is a better option when it comes to that. Their entry, they don't want a high entry. They want to, they're thinking eventually I'm going to have a wheelchair or a walker. I don't want 3 or 4 steps to get up into my house. I don't want to have to monitor and take care of a basement. I just want something that's very simple to take care of. We talk about basements as storage. I'll talk a little bit more about this later. You can incorporate storage in other ways into a new construction home than relying solely on a basement. If that's the main concern, that you're picking a basement, is you love the storage, and that's, access to utilities, but I just like having a basement. Storage is not something that should be the only factor that goes into why you want to have a basement foundation. And so within that, I'm going to talk a little bit more just strictly about slab foundations and T-shaped slab versus frost protected shallow foundation. I'm just going to refer to the slab as frost protected because that's what we use here in Pennsylvania. Traditionally, our slab foundations are frost protected shallow foundations. T-shaped slab foundations have similarities to both traditional footer foundations and slab on grade. These are used in areas where, like I said, it's colder climate, and freezing. And so you're relying on the depth of the footer to mitigate any frost heaves. Generally, there's 3 separate pours or 2 pours, and then you're going to have a block crew come in. It takes longer to build than a monolithic slab or a frost protected slab. And it's more expensive than a frost protected slab just due to the complexity. I mean, you're still dealing with a footer down here, and you still might have, if you're building in a slope where you might have water coming down, so you still might need to deal with drain tile and all the other water mitigation that you might have to deal with. Granted, you're not going to have to deal with water moving into the basement, so there are some things you don't have to deal with as far as a traditional foundation goes, but you still might want to have to take into consideration all those things. And a frost protected shallow foundation, you can tell just from the picture, there's a lot less complexity to these things. There's a lot less grading than you're going down here. For us, it would be about 36 to 40 inches where we're going to need to excavate down to for that footer. For a monolithic slab, if you have the right lot, and if you're not having to do a lot of grading, I mean, you can have a slight grade. But if you have a relatively shallow, flat lot, these are extremely easy to put in. And insulating these things is a lot easier as well. They're much simpler, easier to design. They're very cost effective. They have been around for a very long time. In the Scandinavian countries, they've been using these things for over 50 years very successfully. And they have a tried and true method for doing this. And basically, I think, if Canada really researched this a long time ago, and the Scandinavian countries took their research and actually implemented it over there really before it started taking off in Canada. Canada was more like the US. They were slower to implement these things because they were used to a traditional basement foundation, digging deep footers, getting below the frost line. Um, and, and like I said, this frost protected shallow foundations is different than a slab just because there is you're relying on both insulation and the building heat and just geothermal heat to help raise the frost line and deal with eliminating frost heat potentials. Again, traditional frost protection is achieved through depth. You know, and FPSF is frost protected shallow foundations use insulation. A little bit about frost heave. There's 3 conditions that need to be in place for a building to have this become an issue. You need to have moisture, freezing temperatures, and you need susceptible soils. If you can eliminate one of these 3 out of the equation, you will not have an issue with frost heave. You need all 3 of these to really have it become a problem or a potential problem. Susceptible soils. Pennsylvania, there's a lot of areas in Pennsylvania that have a lot of clay. Clay soils hold a lot of moisture and are very susceptible. There are parts of Pennsylvania, more I'd say on the East Coast, east part of Pennsylvania, where they're more sandy. So, but anyway, I'm not going to get too much into soil conditions right now, but frost protected shallow foundations is here to eliminate the freezing temperature. That's where this type of foundation becomes a benefit. I do want to talk a little bit about moisture issues. Moisture is controlled in 2 states. Obviously, you got a vapor and you got a liquid. So either you're going to have vapor is why we use the plastic, the poly sheeting underneath the foundation. We want to sort of eliminate that vapor that's coming up through the ground. Vapor contact with foundation. There's always high humidity down there under the ground. Especially here, we're not a southwestern climate where you have very dry soils. Liquid comes from a few sources, obviously rain, improper grading. You could have a high water table and uncontrolled foundation assemblies. That really has more to do with T-shaped foundations where, we have water issues down at below the footers. Improper grading is an issue that when I used to do home inspections for building sales, residential sales, I would say most of the issues we had with water issues was from improper grading. We're getting much better at that, and it's an easier fix than people realize. But yeah, controlling moisture and liquid there's a few different ways to do that. Managing controlling moisture. A couple of ways to do that. Manage excessive exterior ground surface water by proper grading to the site. We do have codes which require a certain level of grading. And when possible, you can extend the eaves of your home if that's a possibility, just to push the eaves out a little bit more than a traditional, say, 6 to 12 inches. Install proper size gutters and downspout that direct waters away from the foundation. That's something that is an easy fix when we have basement problems with water. One of the first things that you look at are, what are the downspouts doing? If they're going into the ground, obviously we eliminate that. We don't want those going into the ground anymore. We want to visually see the water turn and leave the foundation. And undersized gutters is an issue too, especially if you have a rather large roof or a large section of roof. Install a drain tile if soil conditions warrant it. Like I said, it's not always a requirement for slab-on-grade or foundations, but that doesn't mean you can't use them. And people do use them all the time with slab-on-grade foundations. And obviously the last 2 is really, these also are obvious things to do. You install a vapor retarder below the slab. And these are all things that we are familiar with. Just a traditional basement, you're just going to follow the same procedures with a slab on grade. And like I said, frost protected use a combination of strategically placed insulation in conjunction with building and geothermal heat to raise the frost level. So like I said, our frost level here is 36 inches. You know, you're using both insulation and the building heat to raise that level up to a point where you don't need to go into the ground as deep as you traditionally would. And again, that helps save on grading and all the other expensive parts of digging a foundation. A little bit on the codes. You know, ASC 32 talks a pretty good in-depth about shallow frost foundations. They're mentioned in the IRC. You know, it's a pretty simple layout or how-to. And there's a book called Design and Constructions of Frost Protected Shallow Foundations. There's a few different ways to find this. It's a good book if you're interested in learning more about them. It's sort of the Bible that leads into how these things work. And if it's something that if you are ever considering a frost protected shallow foundation, if you've never done one before, I recommend this. It's not a real thick book. It's not like a novel or education book you're going to see here. It's relatively simple and it's pretty short. And our 403 in the IRC talks about frost protected shallow foundations. A little bit of things I'd like to mention here for buildings where the monthly mean temperature of the building is maintained at not less than 64 degrees. That's important. Because like I said, when you're putting this thing in, you're relying on a couple of things. You're relying on, yes, insulation, but you're also relying on heat from the building and the surrounding soil to raise that frost temperature. So if you're somebody who's going to build a cabin, and you're going to build this type of foundation, or if you have a client who wants a cabin in this type of foundation, the one question you got to ask them is like, hey, you're going to be gone for months at a time, probably in the winter. Are you willing to leave the heat on to at least keep the building temperature up high enough where this type of foundation works properly? And if it's something they're like, no, we want to be able to shut everything off, then a frost protected shallow foundation is not, would not work for them. And here's the diagram. Obviously, you can see a combination of vertical and horizontal insulation on this foundation. And it looks like a traditional slab-on-grade foundation as well. But like I said, the insulation is the difference. And within the table of 403, you know, what determines what type of insulation you're going to be using and how much insulation you're going to use is what they use as an air freezing index. I'm not completely knowledgeable about air freezing index. I know it's the freezing days over 100 years, I believe. It's like the average what you're going to get. But within Pennsylvania, I'm just going to talk about, we have either 2,000 or 1,500. I can't name all the counties, but you know, it's pretty easy to figure out which ones. Like Center County falls within the 2,000 index. Gives you a minimum footing depth that you need to have for that, and you know, 12 and 14 inches respectively, and that's depth below grade, and it has a vertical insulation R value. So what they're talking about is you need at least 14 inches of 5.6. That's not very much insulation. And then where we are in Pennsylvania, you need no horizontal insulation. Like this diagram shows horizontal insulation. This for us would not be a requirement for a frost protected shallow foundation. Obviously, when we start getting up into colder climates, then yeah, that's where it becomes more of an issue. But nowhere in Pennsylvania do we fall out of the 2,000 or 1,500 category. And you know, if you're looking at the code, this is the 2018 code for foundations, table 403, R403. They're in alignment with what's required now. You're not looking at anything bigger than a normal slab-on-grade foundation. I think the only difference, I think the 21 code is a little different down here with a one-story slab-on-grade. I think it goes to 13 by 6. But I'm throwing this in here just to show you, they're not very big foundations that are required, very big footers that are required when you do a slab-on-grade. And here's the cross sections from that section as well. A little bit about the climate zones. We're all very familiar. We are 4, 5, and 6 in Pennsylvania. That has a potential to change if we do go into the newer codes, the 2021s, but we're not going to go colder. I think we just lose 6, and some of the 4 changes to 5. I'm sorry, the 5 changes to 4 and the 6 changes to 5. So, but that as of right now, we are still 4, 5, and 6. We do, just because you're using a frost protected shallow foundation, you still need to think about code, because you still need to use the energy code that we are currently using. And in 4, 5, and 6, obviously, slab, R value and depth, we needed R value of 10, and we need 2 foot of that continuous insulation. We've talked about this in a few other webinars. In zone 6, you need R10, you need 4 feet of continuous insulation. This is a good example of that. If you look on the right, it's a T-shaped slab foundation. Getting this is a pretty straightforward method. You have your combination of vertical and horizontal. As long as this is R10 and this is both R10, you fall within code. There are exceptions if you follow the PA alternative. There's ways to sort of modify this a little bit, but for us right now, strictly code speaking, in the traditional sense, this is how you're going to go using horizontal insulation to meet the current energy code requirements of Pennsylvania. Energy code still needs to be met. And if this seems like it's getting complicated, there are companies out there now who are specializing in kits for frost protected shallow foundations, where you can go to them and say, like, this is the size of the house, and they will actually engineer and create and mail it to you or ship it to you, the slab kit that you're going to need to put your foundation in. This one down here in the lower left is a pretty interesting one. This is Leggett, I believe is the name of the company. If you look at all these big tubes inside of here, they're actually using heat. They're creating a heated slab foundation, and they're not using liquid, they're using air. So in the center or somewhere in their design, they actually have a heating unit that you create and you put into the foundation as well, which sits flush with the foundation. It's a pretty interesting method of heating. Obviously for us, northern climates up in Canada, where air conditioning might not be as big as concern as it is for us. Pennsylvania, unfortunately for us, we can have very warm summers, very humid, hot summers. And this is only a heating system here. So if you want to condition space, that's going to be a little bit different.
That's great. Thank you.
All right, I'm going to try to go a little faster here. Air sealing. Does the builder do anything different from traditional basement and air sealing? Nope. It's the same thing. You still have to have, and you still want to make sure that you create a good air seal. What would be your sill plate is different. Obviously you don't have a sill plate with a slab-on-grade foundation. You're just using the bottom of your wall assembly. And like any other wall assembly, you just want to make sure you have a nice tight air seal down there. Blower door testing, does a slab-on-grade different from a traditional basement blower door? No, it's the same test. You're still required to reach 3 ACH 50. We're all getting more familiar with that. Mathematically, It does make a difference, obviously. Mathematically, it kind of hurts you to have a slab on grade. I'm going to be honest with you, because if you look at the formula for slab on grade foundation, um, you know, you have the reading from the machine, which is C cubic feet CFM 50 times your minutes 60, and then this V is the deciding factor. It's the overall volume of the interior of a house. So the bigger this number, obviously, the easier it's going to be to reach your 3 ACH 50. That being said, we are becoming better at understanding where potential leaks happen, better at air sealing in general. So yeah, you're going to need to have a little bit more thought with your air sealing, but it's the same. It's the same requirement, the same test, so on and so forth. Pre-planning utilities. This is what scares people a lot. Your drains for your plumbing are going to be something you're going to need to consider in advance and make sure they're laid out properly. You don't want your drain lines going in at this point in the wrong spot. That just takes a little bit more time, a little bit more conversations with your plumber. But it's something that we've been doing they were doing down south for a very long time, and it's not that hard to do, but you just want to make sure it's done properly. Radon. So let me ask the question of radon. Everybody thinks of radon in basements. Radon is still an issue if you have a slab-on-grade foundation or a crawl space. I used to do radon testing, and I did a house here in Center County one time with a slab-on-grade foundation. It had carpeting, so I couldn't see the condition of the slab and how cracked or what the problems were. But the first floor of that slab foundation tested over 60, and I think the number for radon is anything over 4 or 5 needs to be talked about mitigation. So yes, you still need to pre-plan for that. But again, it's a minimal expense at this point right here than it is to try to go in afterwards. You're only looking at $1,000 to $1,500. Here's something that people really want to know about cost comparison. This is a 1,200 square foot house, a full basement. The average cost in the U.S. for a full basement is $38,400. Obviously, if you run into issues with excavation and digging, if you dig in town and if you build in town and the soil you're planning on using as backfill, you can't store on site. You got to pull that out and you got to store it and you got to bring it back in. All these things add to the expense. So I would be more, healthy number. I think for us would be a little bit more than 38.5 for parts of Pennsylvania. And a monolithic slab is what we're talking about here is around 12,800. So that's a pretty considerable difference. You're looking at $26,000 difference in the cost between a slab and a full basement foundation. And if your goal as a builder is to bring that price point down, is to start making these houses more affordable, this is something you want to talk to your client about. Yes, you're going to be missing out on certain aspects of a basement, but you're going to be saving yourself a considerable amount of money that you're going to be able to put into somewhere else in the house. As energy codes increase, as potentially exterior insulation becomes an issue, where all these things are going to become more expensive, you're going to start looking for areas that you can start really cutting big numbers out of your budget and your overall costs, and this is one of them. And additional benefits of a frost protected shallow foundation: they're faster. Your timeline is way shorter. They're way cheaper, as I just pointed out. Easier pest management, yes. I mean, maybe slightly. I would still recommend, if you're going to put one of these in, is still put a termite shield in if you can, if it fits within your air sealing diagram or your air sealing system. It might not stop termites, but it's a good visual indicator. You'll be able to see termites trying to work their way around something like that, especially if you're building in a thickly, heavily wooded area where termites are going to be an issue. They're lower maintenance. As long as it's put in properly and you don't have cracking issues. But if you follow all the proper procedures, a shallow foundation should last for a very, very long time. And if you have the option of in-floor heating as well. I've actually seen a few of these, and I did a couple of them in the Asheville, North Carolina region. It's a very nice way very comfortable way to heat a house. And you don't have to deal with the picture here. We've all dealt with this, digging a foundation hole, and then it rains for 3 or 4 or 5 or days or a week, and then you're dealing with just water issues all the time. Cons of a slab foundation, again, the inaccessible to utilities. Once the slab is poured, that doesn't mean you can't eventually go in there and add something, but you can imagine the cost and the all the work that's going to go in to trying to jackhammer up the floor and running more plumbing lines. But most of your utilities, the only utilities you're going to be dealing with within the slab are drain lines, unless you're doing some sort of in-floor heating. Everything else can be run once the framing is in place. And again, like any other building system, you need to pay attention to details. This is just another thing that we always want to, it's in the details, it's in the details. Pay attention to what you're doing. If you're unfamiliar with a certain type of building procedures, reach out to somebody. Maintenance and long-term performance, obviously maintenance requirements for slab foundation, and how do they hold up over time? Maintenance is pretty simple. You want to monitor your water and moisture around your property. If you start seeing standing water close to your foundation, you want to investigate, why is that happening? Is it my grading has settled down to the point where I need to bring in more soil and I need to regrade around my house or my foundation? Landscaping is not, don't plant trees. This is with any foundation. Don't plant trees or deep-rooted anything landscaping that's gonna potentially get underneath your slab. You want to keep all those kind of plantings away. And if it is a frost protected channel foundation, you want to make sure that you always have your structure heated. And if this is a structure where you're going to leave the heat on for a long period of time, you want a way of monitoring that. Like if you're going to be gone for 2 months, and your heat potentially could go out, do you have a way of knowing this? Do you have an alert or a system in place to let you know that you've lost the heat in the building and you need to go and deal with that? Long-term performance, slab-on-grade foundation have been used successfully in the US for a very long time. Like I said earlier, we have them here that I know are over 100 years old. And yes, I have seen some pretty bad cracking and settling, but nothing that can't be repaired. And these were all put in well before modern building techniques or code was an issue for them. They didn't understand gravel. They didn't understand, underground drainage. So even just the way they put it in back then, they're still functioning and still working today. And as far as frost protected shallow foundations go, they've been used in extremely cold weather climates for a very long time, over a half a century. And they've been used very successfully. So the bugs have been worked out. Any potential problems have been worked out. So there really is no reason to look at this and not think of this as a system that could not work for me in almost any location we have here in Pennsylvania. In summary, slab-on-grade are an excellent alternative. They're an excellent alternative to a traditional basement foundation, especially when trying to lower your costs. Like any other decision, you're going to have some conversations, not only with the builders, but also with your clients, and ask, does this fit what we need? Does it fit our site requirements? Does this fit our lifestyle? So again, start asking these questions. And as far as clients go, you want to ask these questions very early on in the process. I'm going to try to hit a couple of these questions real quick. Yeah, Paul said tornado shelters. Yeah, this won't. You're losing your tornado shelter. From an HVAC view, low return or returns on forced air heating systems should be required for slabs and PA if occupant comfort is to be met. Yeah, it like I said, utilities becomes more of an issue. And then you are going to need to have lower returns installed. But then again, that's going to add a little bit more to the expense. But overall, it's something that can't be overcome. Is there a calculation for multi-story foundations? I think what that would just be is again, you're going to need to refer to code on that as far as footer size. You still need to make sure that you're following all applicable codes when it comes to installing footers. But as far as a frost protected shallow foundation, no. Shallow slabs for manufactured homes. I guess it would really depend on how the home is set. I don't think it's going to work. Number one, because with a slab foundation, you don't have a first floor framing. So, yeah, as far as a manufactured home, unless you can get them to design and build one without floor system installed, yeah, you could probably do that. That would be where a crawl space would come into play. All right, I think I'm finished. If I have any more questions, if you have more questions, please feel free to reach out to me. Um, you know, my email is on our website. It's dtw153@psu.edu. If you go on the PHRC website, you can find me. If I said something that you completely disagree with, please reach out as well. I take criticism very well. And I'm going to turn this back over to Rachel